Okay, welcome to Foundations and Pre-Calculus Math 10 with Mr. Johns. Today we're going to do section 2.4, which is the sine and cosine ratios. So yesterday we looked at tangent ratio and we were using it for right angle triangles. Today we're going to look at sine and cosine, which are just two more ratios of sides. So, sine of an angle, in this case we're talking about angle A, is the length of the opposite side over the length of the hypotenuse. And the short form I like to use for this is SO. Sine equals opposite over hypotenuse. The cosine of A is equal to adjacent over hypotenuse. So if I'm doing the cosine of A, I would do the adjacent side over the hypotenuse. And the hypotenuse is always the longest side opposite the right angle. So my short form for cosine is ca. So the cosine of an angle equals the adjacent over the hypotenuse. And if you remember, tangent was TOA. So SO, ca, TOA. So now we're going to find the sine and cosine of an angle, and these are just going to be decimal numbers that we can use in the future. So to find sine d and cos d to the nearest hundredth, which would be 2 decimals. Here, d is this angle. If I'm going to do the sine of d, I'm going to have the opposite over the hypotenuse. So in this case, it will be side EF over side DE. EF has a length of 4.0 and the hypotenuse has a length of 8.5. So 4 divided by 8.5 equals 0.470588, and to 2 decimals I'm going to say 0.471. I'll round up my 0 to 1 and I have a dot over my equals. When I do the cos of d, I want to put the adjacent side to d over the hypotenuse. So the adjacent side will be df over the hypotenuse, which is ED. The length of DF is 7.5 centimeters, and the length of the hypotenuse is again 8.5. So now I'll do 7.5 divided by 8.5 to give me 0.88235529, and rounded to two decimals would be 8. Sorry, I should have rounded this one to the 0.47. Okay, to find the measure of a missing angle, we can use sine inverse or cos inverse key on a scientific calculator. So we're going to use the sine or cosine ratio to find the measure of the angle. So for number 1, we want to find the measure of each acute angle to the nearest degree. It says find the measure of angle U. So mark your angle. UV is this side, and that would be actually adjacent to angle U. UW is the hypotenuse. So use the cosine ratio, because I have the adjacent over the hypotenuse, which is cosine. Cos of U equals, they want to say the side adjacent, but I'll just say UV over UW, which is equal to the adjacent over the hypotenuse. In this case, it's 5 for UV and 9 for UW. 5 over 9 will just be some decimal, but I don't want to write down that decimal. I just like to leave it as 5/9. To find the angle U, I'm going to take 5 divided by 9 equals this decimal I was talking about, then shift cos, which will do cos inverse, to give me 56.3 degrees. Well, I'm also supposed to find angle W. So, angle W in a triangle, this is 90, this is 56.3, so there's only, the whole triangle has to add up to 180, so there's only 90 degrees left. So 90 minus 56.3 will give me 33.7 degrees for angle W. So this is approximately 56 degrees, and this is approximately 34 degrees. Okay, let's try the next one. Angle U again, here. ST, however, is opposite. All the way across the triangle. SU is the hypotenuse. It's opposite the right angle, and it's the longest side. So we use the sine ratio, because sine, when I'm thinking so, ka, toa, sine is opposite over hypotenuse. So the sine of angle U is equal to ST over SU, which is the opposite over the hypotenuse. So sine of U equals 10.8 over 18. And I'm just going to leave it. I'm not going to write it as a decimal like they want me to. I just want to leave it as a nice rational number. Then I can take sine inverse of this number to give me angle U. So 10.8 divided by 18 equals 0.6. Shift sine gives me 36.86. So I'll say 36.9 degrees. And that's this one. This one's 90. So the whole triangle has to add up to 180. So there's only 90 minus U will give me S. So 90 minus 36.9 will give me 53.1. Whoops. So this is approximately 37 degrees, and this one is approximately 53 degrees. So I used sine to find the angle, and I used cosine to find the angle. One more example. Now we're going to use sine or cosine to solve a problem. So again, we have a ladder leaning up against a wall, as shown. What angle does the ladder make with the ground? Give your answer to the nearest degree. We want to find angle D. So DF is here, and relative to angle D, this is the adjacent side. DE, in this case, which we're given as 8 meters, is the hypotenuse. So the adjacent and the hypotenuse, we have to use the cosine ratio. So cos of D is equal to the adjacent side, which is DF, over the hypotenuse, which is DE. Using their lengths, we will say 2 meters over 8 meters. So cos of D is equal to 2 over 8 is the same as 1/4. Now I'll do cos inverse of 1/4. So here I substitute DF equals 2 and DE equals 8. And cos inverse 1 divided by 4 is 0.25. Shift cos is 75 75.5. So angle D is equal to 75.5 approximately degrees. So this is about a 76 degree angle. One more here. The string of a kite is 160 meters long. The string is anchored to the ground. The kite is 148 meters high. What angle does the string make with the ground? So they want me to use this angle, angle V, and then TU is opposite this angle, and this one is the hypotenuse, the string. So I'll have to use the sine ratio. I'm not going to solve it. It's very similar to this, just using sine instead of cosine. Try it. Ask Mr. Johns if you need help. So this is one for you to do for your assignment. I would also like you to do all of number 1. All of number 2. All of number 3. And number 4. You don't have to do number 5. So, your assignment for section 2.4 is numbers 1 through 4, all. Good luck. Let me know if you need help.